Okay, so basically, so for this one, you're essentially just, using the formula for compound interest for different n's. This is what you get: compounded annually, compounded quarterly, right? Monthly and daily. So for annually, right, in that case, your n is 1. So, excuse me, p sub 0, right, the principal, in each case here, it's $10,000. Your r is 0.05 in each case, and 5 years, so t is 5 in each case. The only thing that's really changing here is n. Your n. So for this case, n is 1, compounded annually. So that's why here we have 1 and a 1 here. This is what we get. Here, quarterly, n is 4. So this is 4, this is 4. We get this. N is 12, n is 12, right? Because monthly, 12 months in a year. Get this. Daily, 365 days a year. So we have this amount. So this is what we get in this case. Okay, let me just do this. Same numbers. Okay. Let me just check something, though. Did everyone get these numbers, though? Let me just check that. I want to make sure you know how to use a calculator. So, okay. Even if your idea is right, if you push the wrong button in the wrong order, your answer is not going to be right. So you have to be careful. That's why I like to have people show their work generally, because if something goes wrong, and they show their work and their work is correct, I can give them most of the credit. So it looks like everyone did. So I'll take that as a yes. Well, almost everyone, it looks like. All right. I guess we're good. All right. So of these 4 choices, you could probably answer this easily. Which one would you prefer? Well, not to mention the answer is here already. Daily, right? Compounding daily, you're going to earn the most amount of money. It's not much more than monthly. Here it's only about a little less than $7, but it's still the most. Okay. Definitely a lot more than annually, as you can see. Well, even then, I guess. But either way, daily, you earn the most amount of money by compounding daily. Now, one can then ask, what if we compounded all the time, beyond daily? Like every hour, every minute, every second. Can that be done? Can we consider the case when it's always being compounded? Well, the answer is yes. That's where continuous compounding comes into play. In other words, I did write up here, if you were to increase the number of compounding periods without bound, in other words, in a full year, okay, in a full year, if you allow it to compound constantly all the time, never not compounding, the amount in that account would be this. So let me say that again. If the number of compounding periods, meaning the number of times it's compounded in a year, if you let that increase without bound, increase and never stop, so that it's compounding all the time, then the amount in that account would be this. It would be given by this wonderful formula. I think people call this PERT. The notation's the same except for the E, but the A, that's the balance. After T years, P sub 0 is the principal. R, right, that's the APR in decimal form, not as a percent. T is number of years. The only thing really different now is E. This E. But there is a button on your calculator labeled E. You might see E raised to the X. I think in the iPhone calculator they have that. I know in the Desmos calculator they have that as well. It turns out that E is in fact a number. It represents a number. It's irrational, meaning you can't write it as a fraction. So in decimal form, it's not terminating, so it doesn't stop and it's not repeating. The digits don't repeat in a pattern, kind of like pi. It's also a number between 2 and 3. I think as an approximation, you can use like 2.71, I think. But what the number E represents, why it's so important, that's really unfortunately beyond what we do in this class. I mean, to really get into it, you would have to know calculus. To even see how E is defined, you would have to. But this is the formula. But this is the formula for continuous compounding. They don't do this in the book, but I wanted to do it for fun. So since E is a number, this is an exponential function. It's actually named after, they used E to represent the number. E after Euler, I hope I'm saying his name right. He was, I think, a Swedish mathematician. So I don't remember what century, though, but he was a famous mathematician who did a lot. So I think he was actually blind, and he still published. So, okay. All right. Anyway, so we have continuous compounding. So I threw in an example here. So let's say it was being compounded continuously. How much would be in the account then? So let me say it again. Let's get the amount in an account after 5 years if we deposit $10,000 and that account is earning 5% interest and it's being compounded continuously. Well, then the amount there, okay, it's going to be given by this formula. Now, is compounded continuously, is that something that's actually done? I honestly don't know. I want to say it is, but I can't think of any examples. All right. So let's see. Okay, so I hope that makes sense. All right. So let's keep going. Let's do some other stuff. So this is something else in chapter 5. It's what they call the annual percentage yield, the APY. And you could hopefully you could tell by the formula here. Well, it's actually the percent increase in the balance after 1 year. So again, we're compounding, we're in compounding. And the percent increase in your balance after 1 year, that's what this APY is. I mean, you can kind of see from the formula, it's the percent change actually, or the relative change. The balance after 1 year, subtract the starting amount, divide by the starting amount. It's the percent change, it's the relative change or percent change of the balance after a year. And you could do basic algebra just by factoring and dividing, and you end up getting this formula. So it only depends on R and N. R, remember, is the annual interest rate or the annual percent rate as a decimal, not as a percentage. N is how many times it's compounded in 1 year. So it's kind of interesting in that it doesn't actually depend on the principal, what the APY is. So I thought that was cool. Here's an example. So let's suppose let us calculate the APY for an account that pays 4% compounded monthly. And we want to round this to 2 decimal places. So we want to calculate the APY for an account. Okay, that pays 4% compounded monthly, round to 2 decimal places. So in this case, N is 12. It's compounded monthly. The R would be 0.04. If you do the calculation, you get 0.0407, which is 4.07%. I think it turns out that APR has to be less than the APY. I mean, in fact, the APR is what you get if N is 1 in this case. That's just by direct calculation. Okay. All right, let me, before we do this, let me just do that recording stuff. Let me stop that.